If any block, for example, a snatch block, a marine block, a tubing block, or a crane block, is not maintained properly, it can become a safety hazard. The first point of inspection is visual observation. If a block, or any of its components or tackle, such as shackles, wire rope end connections, hooks, eyes, or wire rope, etc., show signs of permanent deformation, significant wear or damage, the component should be taken out of service immediately and replaced. Let me repeat that. Never use a block or any tackle component which shows signs of permanent deformation, significant wear, or damage. The side plate of any block is an important point of inspection. If a side plate is bent or curved from its original shape, or holes in the side plate are elongated or stretched, the block should be taken out of service. There should be no play or looseness of a side plate. If a side plate is loose, this is likely a sign that the nuts and/or bolts used to hold the side plate to the block have loosened or are missing. Tighten all nuts and bolts until the plate is attached firmly to the block housing. Never use nuts or bolts with stripped threads or bent shanks. For safety's sake, replace missing or damaged nuts and bolts with genuine Crosby parts to ensure proper strength and fit. Many blocks are provided with swivel load connection fittings, including hooks of various styles, shackles, or eyes. Visual inspection of swivel fittings should include shoulder running clearance, lateral movement, wear and deformation. The hook being demonstrated is a single point type. Regardless of the specific design of a hook, the maintenance rules remain the same. It's important to remember there is no substitute for regular visual inspection in the field as the first step in a good maintenance program. The shoulder running clearance between the swivel case and the shoulder is generally set at 1/32 to 1/16 of an inch at the factory. Clearance is greater than 1/8 to 3/16 of an inch, or excessive lateral movement, may indicate dangerous looseness or wear of the assembly. Disassembly and further inspection of the unit is required. Any fitting attached to these blocks or tackle in a block and tackle system which exhibit any deformation or wear in excess of 10% of its original dimension should be removed from service. Inspect your hook assemblies frequently to ensure the nut retaining pins and/or set screws are in place and firmly tightened. Inspecting the internal parts of a block requires disassembly. Thrust bearings should be inspected while the block is disassembled for excessive wear or deformation, such as flattened rollers or uneven races. After internal inspection and before reassembling the block, always use a thread sealing compound, applying it to the threads of the hook shank and the nut. Most field inspection of commonly used tackle will be visual, closely looking at tackle components for signs of unusual or substantial wear or deformation. Regardless of the tackle component involved, however, always inspect all nuts, bolts, and pins used in the component's assembly. Retaining nuts on all bolts and pins should be checked to ensure they haven't backed off or loosened during operation. It's important to retighten any loose nuts and pins and then lock them into place using the original locking method and device: stakes, set screws, cotter pins, retaining rings, or cap screws. Do not try to substitute locking devices. This will affect the integrity of the locking device and could create a safety hazard. Pins held in place by retaining rings should be retained only in that manner. Do not weld them in place. An internal component of blocks requiring regular inspection and maintenance are the sheave bearings. Please note, it's impossible to properly inspect the bearings for wear unless you disassemble the block. However, an external sign of possible bearing wear is provided by the sheave. If the sheave is loose or wobbles like the one you see here, this is a sign of possible bearing wear. The next step in this case would be to disassemble and fully inspect the bearings. The type of bearings used in the sheaves will determine how they must be maintained and lubricated. A sheave gauge is a tool to measure minimum sheave groove diameter. This measurement should be included in your regular inspection. The gauge is seated into the groove of the sheave and should fit flush with the bottommost point of the groove. In case of significant groove wear or deformation, the gauge will not seat properly in the groove, but rather will show daylight between the gauge and the bottom of the groove. As you can see, this sheave has been worn to the point where the wire rope will not seat in the base of the groove as it should. The result will be further wear on the sheave, wear on the wire rope, and eventually the creation of a safety hazard. The only solution is to take this sheave out of service immediately. Other points to inspect for are bent flanges, cracked flanges, worn hubs, cracked wells, cracked spokes, and any evidence that a sheave is loping or wobbling around its center.